Hello and good evening, ladies and gentlemen, and welcome to York University and the May Recreational Astronomy Night for the Royal Astronomical Society of Canada, Toronto Centre. My name is Tom Luton. I'll be your host for the evening. Our lineup for the evening, we've got Andy Beaton with The Sky This Month, Denis with Occultations, Then and Now, and following up with Ed Trace, I Want to Be Left in the Dark. This was a presentation that was supposed to happen last month, but as you may recall, the weather conspired against us, and so we had to bump Ed's presentation to tonight. Afterwards, then there's going to be announcements from our president, Scott Masterton, and then after the meeting, there will be telescopes set up by York University on the roof of the Arboretum parking garage, so you can take a look at the moon and whatever else happens to be up in the sky tonight. Um, Quick show of hands. Anyone here for the first time? Welcome. All right. And speaking of what's going on in the sky tonight, Andy Beaton with The Sky This Month.
Hello, my name's Andy Beaton. I've been doing this a few times. I expect a few of you will recognize the routine I'm going to go through, but I'm going to talk about what's up in the sky this month. And I'd like to thank everybody who has taken time out from watching hockey to join us tonight. I have my usual list of things I like to go through, the big picture, key dates, the sun, meteors, the aurora, the moon, planets, asteroids, and comets. Always a double star, absolutely always a variable star, something in the deep sky, whatever's coming up in the world of spaceflight, and some backup plans just in case it's cloudy. So the big picture, if we head out there tonight at 10 o'clock, look west, this is what we're going to see. Our favorite winter constellations are finally disappearing. Orion's just sticking his nose up above the horizon. Your spring constellations, Cancer and Leo, are following. Pretty good night for the moon if you like that kind of thing. The Terminator's halfway through, so you can see some good shadows on the craters and mountains. But not much in the way of planets. Jupiter's kind of disappearing there. Mars is still good, but other than that, not much. This is the kind of month I hate, where there's nothing really spectacular happening in the sky I can talk about. But by the next meeting, things are going to start happening again, especially in the morning sky. Get up at 4 o'clock before we have any sunlight showing up. We'll start to see all our favorite planets showing up just over the horizon. We have our summer constellations. We've got the summer Milky Way. And we're ready for all our favorite summer viewing. So important dates coming up. The first one is a date that's actually passed. The Eta Aquariid meteor shower peaked last night, but it's a 5-day long shower, so we should be able to see some as long as we're under reasonably dark skies. Another one that's passed, Saturn's ring plane passed the sun, so the other side of Saturn's rings will be illuminated for a good long time. May 27th is going to be the new moon. That's when all our photographers are going to be out taking advantage of the darkest sky we're going to get this month. And we have our last double moon shadow on Jupiter. If we're ever observing Jupiter through a telescope, every now and then one of Jupiter's moons will cast a shadow on the surface. When things are properly lined up, like they will be this month, you can get 2 shadows at the same time. So that's something to look forward to. It's interesting more than exciting, but your observer's handbook will have exact time and end dates for your shadows on Jupiter. So the sun, nights are getting longer. Astronomical twilight is ending at 10:15 tonight, starting again at 3:40 in the morning. So we don't have a lot of dark sky to observe in, and it's just going to keep getting worse. By the next meeting, twilight ends at 11:10 and starts again at 2:50 in the morning. And it's going to keep getting worse until as we approach the summer solstice. What the sun is good for right now is activity. There's a massive sunspot group on the surface of the sun right now. I haven't been out to see it with a solar telescope myself, but I've seen it reported online by a number of people. It's a nice big one. The thing I hope is that this kind of solar activity is going to result in a nice bit of aurora for us to look forward to. That's about all I can really hope for from the sun. It's not really looking like there's anything predicted for tonight or the next few nights, but we've got a whole month ahead of us. Meteors, it's not a great meteor time. The best we have is the Eta Aquariids from last night. We'll still have a few more nights of them. We could probably expect 30 to 60 meteors an hour. The moon's pretty bright, so of those 30 to 60, we're not going to see too many. That's the closest thing we have to a major shower over the next month. We've got a minor shower, the Eta Lyrids, on May 10th. And we have a really tiny shower, the daytime Areatids, less than 2 meteors an hour. I wouldn't go outside to search for them, but if you're interested in a science experiment, dig out your old radio, tune it to a distant station, say Montreal or Ottawa or something. You aren't going to pick it up until a meteor passes overhead. When that happens, the ionization in the atmosphere will reflect the radio, and you'll pick up a brief burst of music or news from that distant station. It's the funnest and easiest way to do radio astronomy, and one of the best things you can do during a day, especially if it's cloudy. So we also have the Tau Herculids peaking on June 2nd. That one's a variable meteor shower. And what that means is you're taking your chances. You might get 1 million, you might get none. I wouldn't plan for anything, but if you're out there and you see meteors, trace them back to the direction they're coming from, see if they're coming from the area of Hercules, and see if you can identify members of this variable shower. So the aurora, as I said earlier, nothing too exciting predicted in the near future. I would watch spaceweather.com as my source of information on when meteor or when aurora are expected. The picture on the screen there is one my daughter took at last summer's fantastic aurora display out on the West Coast. I didn't get to see anything like that in Toronto. I got to see little streaks, but it's not very often you see aurora in the city. So I'm hoping we can get a decent display sometime this summer. I think we deserve one. The moon, full moon's on the May 12th, last quarter on May 20th. The new moon, that's the important one, May 27th, and then the first quarter on June 3rd. Apogee is on May 11th, and perigee is on May 26th. I never remember which one's apogee and which one's perigee, so I threw in a note here. Apogee is when it's far, perigee is when it's close. And if you're looking for a fun science experiment with the kids, take a picture of the moon on those two dates with the same equipment and compare the size of the two images. You'll get to see that there's a real measurable difference. Evidence that the moon orbits in an elliptical orbit and not a circular one. Lunar X, it's going to be in the daytime. For those who don't know, there's a few craters on the moon that once a month they get illuminated at a certain angle and it makes an X, the light shining across the two crater rims. Scientifically, it means nothing, but it's neat. It's a cool thing to look at, and it's a fun thing to have a target to go hunting for. Unfortunately, it's at 9:18 in the morning. I haven't tried spotting in the daylight. I think with any reasonable telescope, you probably could, but I haven't done it. If anybody wants to try it and they succeed, please let me know. I'd be very curious. The straight wall, another lunar feature that looks really cool through a telescope. It lasts longer than the Lunar X, but it's a bigger feature. Anytime during the evening of May 7th, it's down towards the south edge of the moon. It appears as a very weird looking straight line that you don't expect to see on the moon with all its circles and bumps. The rocky planets, Mercury is not really well viewed from here in Toronto. I know in the past we have had people in the Southern Hemisphere listening in on this talk, so you guys are going to get a really nice view of Mercury. It will show up in the morning, nice and high for Mercury. For us, it's an unfortunate angle. It ends up quite close to the horizon for us, even at its best. Mercury, or Venus, is also in the morning sky, higher than Mercury and way brighter. You're not going to miss it. It'll be really obvious, but also at a funny angle. Over the next month, it's heading around the sun to the back, which means it's going to be gibbous. It's growing fatter. It's going rounder. But because it's going further away, at the same time, it's going to be getting less bright. The best of the rocky planets is going to be Mars. It's a first magnitude object in the western sky at sunset, nice and high, but yay high, and setting not long after midnight. Currently 6 arc seconds across, which means with any decent telescope, you should be able to see polar caps. A large telescope, you should be able to see some kind of surface features. But you want to get it while it's as high as possible in the sky, because the closer it gets to the horizon, the crappier the viewing is going to be. It'll be traveling from Cancer to Leo as the month progresses. And once again, I'm going to ask people to see if you can see Mars's moons. Another thing that I have never seen, and I'm curious if other people can manage it. It's tricky. You really need to block Mars out of your view and get that very faint moon just on the edge of the eyepiece, because they're very faint compared to Mars. The gas giants. Jupiter is low in the west at sunset, and it's getting worse as the month goes on. I would not even call it an interesting target at this point. You should be able to see it with a telescope and see stripes and moons, but the viewing conditions are going to be terrible just because it is so low. Saturn is rising before dawn in Pisces, and it's got the same problem. It should be interesting, but it never really gets very far above the horizon during the dark hours. And over the next month, the position is improving. It's getting higher, but at the same time, the sun is rising earlier. So it's not going to get out of dawn twilight over the next month. The other problem with Saturn is the rings are at a very flat position right now. If it were in a better position, I would say that would be good. It would be a good time to look for interesting weather features, look for the small moons of Saturn that are hard to see under other conditions. But right now, it's just a curiosity seeing flat rings. The ice giants, we've been pretty much right off for this month. Uranus is too close to the sun. We're not going to see it at all. Neptune rises in Pisces. It's close to Saturn, but the same problem. It's not going to get out of twilight, and twilight gets worse and worse as we approach the summer solstice. So put those ones on hold until later in the summer. The dwarf planets, it's actually not a bad time to go looking for Pluto. It's in Capricornus. It's just over the border from Sagittarius. It's moving slowly. As it gets further and further away from the Milky Way, it gets further away from the really dense clouds of stars, making it a bit more easy to identify. It'll rise tonight somewhere after 2 o'clock. So by morning twilight, it'll be as high as it gets, and that will improve as the month goes along. 14.5 magnitude, that's tough for visual viewing. There are going to be a lot of faint stars that will make it hard to identify. Best way to go hunting for Pluto is photographically. Take a picture, come back 3 nights later, take another picture, and look for the dot that moved. The other dwarf planet we are able to see is Ceres. It's in Cetus, low in the horizon in the dawn throughout May, 8th magnitude. It's findable. It's not really great because it is going to be pretty low, but you can track its movement. It moves pretty fast, usually about 5 minutes from night to night. And tracking it as it moves would be another interesting science project. Got a few asteroids brighter than 10.5 magnitude. Juno and Vesta are the most spectacular ones. They're going to be not far off visible to the naked eye, probably 7th or 8th magnitude. The others much dimmer, but tracking asteroids is fun. They do move. If you're out from night to night and have the patience to do it, mapping them is interesting. I remember in university actually taking asteroid coordinates and measuring them and trying to calculate the orbit. I had to do it for marks, so it wasn't really a fun project, but it was enjoyable. I'm not going to try and give you coordinates for all these. They're available in the RASC Observer's Handbook or planetarium software, which I expect most people watching this will have on their phones or their computers. When I was complaining earlier about how this is a lousy month for spectacular things to look at, comets was at the top of the list. It is a terrible month for comets. The best we have at this point is F2 Swan, 8.5 magnitude in Taurus. It's close to the sun. You might catch it at sunset, but it's not really it's not going to be a high contrast object. It's marginal at best. The only other one greater than 12th magnitude is A3 Tsushinshan Atlas, just under 12th magnitude in Vulpecula, slowly moving into Cygnus over the next month. 12th magnitude comet is interesting only if you've never seen a comet before and want to say you have. I guess if you're the kind of person who wants to check off every possible thing in the night sky, you can go after it, but it's way, way, way past its peak. So we have to have a double star. This is for my old friend Blake, who got me interested in observing double stars. I'm going to go for a spectacular one this time, Alpha Canum Venaticorum, also known as Cor Caroli, or old-fashioned way, Cor Caroli Regis Martyris. And this is named after King Charles I of England, after he had his head lopped off. Once the monarchy came back to England, they decided that he was a good guy after all, and they honored him by naming this double star after him. So that's where the name comes from, if you're wondering. It's a 2.5 and 5.6 magnitude pair, 19 seconds apart, so any small telescope should be able to split them. They're both bright enough to be seen with the naked eye under a dark sky. Blue and white in color. The bright one is blue, the fainter one is white. I mean, it says green in the Observer's Handbook, but anybody who's ever looked at a star that's supposed to be green knows it looks white. But the bigger telescope you have, the more photons you're going to get, the more obvious the color difference is going to be. And for you younger astronomers, I strongly suggest you take very careful notes of where these two stars are. And every 10 years, come back and take another look and see if you can track it as it orbits the primary. So here we go. There's the finder chart. Up at the top, we have the handle for the Big Dipper. If we consider the handle of the Big Dipper to be the outer edge of the piece of pie, Cor Caroli is right at the center of the pie. It's easy to find, it's nice and bright, so it makes a good party star if you're showing friends and family some cool stuff in the sky. Now, you know you're not going to get away from my talk without a variable star, so here we go. RS Canem Venaticorum, same general area in the sky. It's a close eclipsing binary. We have an F main sequence star and a K, which is a much redder subgiant secondary. And it varies from just under 8th to just over 9th magnitude every 4.8 days. It's your typical eclipsing binary, but it's more complicated than that. The secondary is undergoing rapid spinning. The magnetic field of the primary is messing it up. So it has huge sunspots that change the star's brightness as they rotate around the star. The changes for this are subtle. So you'll want a photometer for this one if you're going to go for the subtle changes caused by the sunspots. But if you're looking for just a regular eclipsing binary, that can be easily done visually. Maps for the variable star can be found at the American Association of Variable Star Observers website. They have charts where they have comparison stars for all the interesting variable stars. You look at this star, you compare it to nearby stars, say, okay, it's brighter than this one, dimmer than that one, it must be 8.5. You can record it, send it in, and join the database of 120 years of variable star data that have been accumulated by amateur astronomers. Professional astronomers, as a rule, don't have time to go looking to measure variable stars over months and years. So that's where we amateurs step up and do our bit for science. And the weirdest of all variable stars, T Corona Borealis. We've been expecting the outburst for over a year now. We don't know why it's not happening. This one is, we had thought, one of the most predictable events in the sky. 1946 for the last outburst. Last year was supposed to be the next outburst, and it hasn't happened. It'll be bright enough to be visible to the naked eye, but we're just not seeing it, and nobody knows why. It's going to be pretty bright. Here we have a map of Corona Borealis with the bright stars and the blaze star down in the corner, so you can have a rough idea where you're going to be looking. If you see it there, get online and report it. This is something that scientists have been eagerly waiting for a long time, and it's going to be people like us who are out there observing every night who are going to tip them off that it's happening. Something in the deep sky, M4, fourth object in the Messier catalog, is a globular cluster in Scorpius. It's easy to find, it's bright, it's 6 magnitude, and it's right beside the star Antares, so nice and easy to find. Closest globular cluster to Earth, about 100,000 stars. A large number of them are white dwarfs. This is a very, very old cluster. Some of the stars approaching 13 billion years old. That's where the oldest observed star in the Milky Way has been recorded. And with a small telescope, you should be able to resolve a number of the stars. I think globular clusters are the most interesting visual objects because they're the ones that look best to the eyeball. Other things, cameras pick up more light. The longer you observe, the more detail you get. Globular clusters, they tend to burn out in the center and just make a white blob with photography. So I like looking at them just with the naked eye. I think that's the best way to really appreciate them. Now, I know that some of the people sitting in this talk are looking for something more challenging than Messier objects. So for them, I'm going to point out NGC 40, 38, and 39, the antenna galaxies. 10.5 magnitude interacting galaxies in Corvus. And this is them. This is actually from the Hubble telescope, so don't expect to see that. But it is two galaxies crashing into each other and all kinds of interesting effects going on there. An 8-inch telescope will be able to find it. Larger telescopes, especially say something over 16 inches, so you'll start seeing the structure and clearly distinguishing the two galaxies. You should be able to see bright patches. You can see the around the edge there where there's a lot of star forming activity as the two galaxies crash into each other, and a lot of dark material around the center, a lot of dust and gas that's going to be, that predicts future star formation as well. And as you can see, I can't type antenna, so we'll pretend that didn't happen. Coming up in space flight, it's actually an alarming space flight time. Cutbacks in the US government mean a lot of the interesting space programs are in jeopardy. We want to keep an eye on that for the near future. An Eris rocket is being launched from Australia. This is a brand new space flight company. May 15th is a scheduled date. As always with test flights, we don't know when it's really going to go, but that's the scheduled time. Cosmos 482, a Soviet Venus lander that failed to get out of Earth orbit, is expected to crash sometime on the night of May 9th or 10th. I don't know where it's going to happen. It could be quite spectacular. The odds of it landing on anybody are pretty low, but keep an eye out for it. The ISS will be passing overhead late night and early morning until May 28th. After that, its orbit is in a position that means we're not going to see it here in Toronto, but other people at other places around the world should be able to see it. Something else that I have found this month on the Heavens Above website is the Tiangong, the Chinese space station, should be visible early morning until May 28th. And after that, evenings low in the south. I think it gets something up to 30 degrees above the horizon. Heavensabove.com is where to go for more details on when and where it will appear. Space stations are just cool things to see in the sky. I love them. You know, seeing an object, a bright object going overhead and knowing there are astronauts up there is just always fascinating. So if you're in Winnipeg to see the jets and you're too far north and there's no night, Galaxy Zoo has an abundance of citizen science projects, places where people like us can go and contribute ourselves to science. They have dozens of projects. I've picked a few that looked interesting this month. Cosmic collisions, sunspot detectives, looking for sunspots and tracking them. Gamma ray burst chasers. That's for helping track down gamma ray bursts. The professional astronomers will gather a ton of data, and people like you and I will go and dig through it and try and track down what is actually happening. And kilonova seekers, for those of you who really love those giant explosions in space when neutron stars crash into each other. Well, who doesn't? So once again, if there are any questions, I'm happy to answer them. You can email me at andy.beaton@gmail.com. I'm on Blue Sky or the Toronto Centre Forum. And thanks very much, and clear skies. And are there questions?
Yes, any questions from the audience?
You mentioned the transits of Jupiter. Titan transiting Saturn, I think it's still visible. Did you get a chance to look into that at all?
Saturn is in such a terrible position for observing right now that I did not. It would take a better sky than its position close to the sun right now to be able to see something like that, I think. Now, I could be wrong. If somebody can observe a transit of Saturn or a shadow of Saturn, I'd be fascinated to hear about it. And yep. And let me know in the places I mentioned.
There are some coming up about once every 16 days or so through September. So,
okay, well, actually, as we get further into the summer and Saturn gets further away from the sun, that would be an interesting observing project, looking for Titan crossing the face of Saturn or its shadow. So yeah, keep an eye out for that. Is this something, Dennis, is this something that's in the Observer's Handbook? Is this something you're going to have to go dig out your planetarium software for?
I'm just looking at something on cloudy nights, but I think
okay,
probably in the Observer's Handbook, but you never know.
Yeah.
And because of the nature of this event, it's only 5 hours. You've got to be on the right side of the Earth to see it. So there may only be 1 or 2 opportunities from North America that'll work out.
Okay, so cloudy nights is the place to look for information about transits of Titan.
Okay, any other questions in the room? No? Okay. And no questions online. Andy, thank you very much.
Okay,
and
thank
ladies and
you.
gentlemen, we're going to go to fun facts while we get set up for our next speaker. All right, and we're back. And ladies and gentlemen, our next speaker of the evening is Denis with Occultations, Then and Now. Denis.
Thank you very much, Tom. And thank you, everybody who's here in person. We've got a good group here tonight and a few familiar faces and a few new faces. So it's great to see everybody. So I've titled my talk Occultations Then and Now as a way of sort of contrasting kind of the way things were 25 or 30 years ago in this particular branch of astronomy with the way they are now, and to try and share with you kind of my excitement on how things have developed very quickly and very organically, as a lot of volunteer people have put a lot of time and energy into making what I consider to be a completely foolproof occultation recording and monitoring system, which is available today. So I'm looking forward to sharing a little bit of this story with you. Before we get into it, though, I think for the benefit of people who may not be familiar, I'll just do a little digression into what are occultations and why do we care about them. We'll talk about how we used to do occultations back in the good old days, and we'll talk about how we're doing it now. We'll highlight some of the new collaboration tools and the new hardware and software tools that are very exciting. And we'll talk about sort of the future of occultations as we go forward. All right. So the first thing is, what is an occultation? And so essentially, it's an event which makes this an event-based astronomy, which is kind of cool. And it occurs when one thing passes in front of another, partially or totally blocking its light, often causing it to visually disappear completely. Right. So that's the cool thing that we see, and you can usually only see it from a specific spot on the Earth, and that's it. So, can anyone name for me one kind of occultation that you may have been lucky enough to go to see recently? Yes, sir, in the back. A total solar eclipse. That's exactly the answer. So, if you think about it, a solar eclipse is when the moon goes in front of a bright object, the sun, and blocks it out. And if you're not standing on the right spot on the Earth, you won't see anything or anything very interesting at all. But if you're in exactly the right spot, you can see it get entirely out of the way that way. So when we're working with occultations like that, astronomers working together can use the combination of information that can be recorded. So we're interested in, when did the star get blocked out by the thing? When did it come back when the thing moved out of the way? And where exactly were you on the Earth when you saw it disappear and reappear, right? So that information, with some math and calculations and a little bit of everything, can be used to actually determine the object's pretty precise shape and size. So this is a profile here of an occultation that happened in 19, I think it was 2001, of the asteroid 90 Antiope. So this was shown to be a binary asteroid. So we weren't sure about the binary nature of this asteroid. We kind of had some measurements that its light curve kept going back and forth in a cyclical manner. But this not only showed us exactly how close they were, we got a sense that one of those asteroids has got a funny shape. And because we now know the size and the distance between them, we can determine their mass and their density and all kinds of other cool stuff about it. So when you think about it in terms of how this looks on the Earth, right? So the geometry is that we've got a bunch of people A, B, C, D, and E, all scattered in different locations, but they all have in common is that they're standing in the right spot to be hit by that shadow as it comes across the Earth. And that shadow can cross the entire Earth in about 5 minutes, 10 minutes, half an hour, depends on how fast the asteroid is going, how far away it is, and so on, right? And so what the observers see is, observer A sees nothing. It missed him or her because he's outside of the shadow path. See, he's up in Edmonton there where the Oilers are. So, but B, C, and D, they see they see that asteroid getting away, and E also misses it. He's down there. So taking B, C, and D together, we get an information about the size of the asteroid, and A and E give us constrain how big it can absolutely be. So that information all put together, it gives us this information, or gives us all of this cool stuff that we find out about the asteroid. And what we're doing when we're looking at these timings is we're looking for a light signature or a light curve signature that shows us exactly when it goes out and when it comes back, right? So if we're trundling along here, it's a certain amount of time, we've got a certain amount of time, all of a sudden one of our stars, the blue star in this display, goes gone, and it hits near zero, and then time passes, poof, comes back, right? So that's telling us the disappearance and the reappearance time. So that's a view of my individual data. So if we think back on that, those chords, I could be B or C or D. This is what I'm seeing when I look at my data, when I review my video recording or whatever. This is what I'm seeing. I'm seeing an out, and I'm seeing a back, and that precise timing there gives us that information. Now, of course, the location is very important. You need to know where you are in the earth. You can't just sort of say, well, I was wandering around somewhere in North Dakota and I think I saw this thing. That's not really very helpful. And so, in order to get everyone working together, a big part of this process is to have predictions. So, you need to know where to go. Where is this going to happen? What star are you supposed to be observing? There's an awful lot of them out there to choose from. And when exactly is this event likely to happen? So that's that. And then, of course, the other, of question of the 4 Ws is, why did I forget to bring my power supply when I went out on this adventure? So that's another question, but that's an existential question for all people that are interested in this hobby. So that the more important why, not just where is my power supply, but this is another example of what Andy was just talking about, which is citizen science. So occultations are really useful in the world of science because they constrain that size of the occulted body. So we know roughly how big that is, and we can confirm both double stars and asteroid satellites with this. So if the asteroid passes in front of a double star, you'll see half of the light go out, and then the other half of the light go out, and then half of the light will come back and half of the other half of the light will come back. It's a very, very visible signature on that light curve, which goes, wow, I've discovered or confirmed a double star. That's pretty cool. Same thing can happen with the asteroid. So if it's a double asteroid like Antiope there that we showed you the example, people that are far away from some other people will see an occultation at a different time. It'll be a different asteroid, so it'll have a different duration. We put all that information together, we've discovered a double asteroid. And also very important and kind of important, for defense and so forth of the Earth, constraining the size of the orbital parameters and getting them more accurate. So if you predict an occultation and you think it's going to happen at this time and it happens 3 seconds earlier, well, that means your prediction was pretty good, but why the 3-second difference? That's a change in the orbital characteristics of that asteroid, which might mean maybe it's had an encounter with some object, something slowed it down. Maybe our astrometry wasn't very good in the first place, and so forth. So that's a little bit about the why, or the what is an occultation. I hope that's clear to everybody. That makes sense. Getting a few nods. Good. All right. So how did this happen in the past? So first of all, location. Well, location didn't used to be as easy as it is now. So essentially, you'd start with a topographical map, and you would see where certain highway met certain other highway, and you'd try to remember where you drove out to, and you kind of do X marks the spot, and then you would go on the map and try to figure out the latitude and the longitude and all that stuff. So you could do it and it would work, but you were never going to be that precise. So you were going to be, probably plus or minus half a kilometer, quarter kilometer, something like that. It was going to be a little messy. And then in terms of observing this, we were using our Mark I eyeballs mostly. This was kind of before video cameras were very popular. They were very expensive. So people were doing a lot of this with just looking through the eyepiece, which meant that you had to keep looking and don't blink, because it could just happen when you're blinking. So you have to keep looking at it and keeping looking at it until it happens or doesn't happen. So anyway, that was always fun. And then timing. The most reliable source of timing was shortwave radio. So there were time signals that would come, and you would basically have a time signal that would go boop in the top of the hour, and it would go beep, 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 and you'd have that regular time signal. You'd synchronize your chronometers, and you'd know that 8 o'clock was the most recent beep, and so you'd count how many boops you had. So you could say, well, it happened at 29.5 seconds after 8 o'clock, and it unhappened at about 33.5 seconds after 8 o'clock. And it was all a bit of a process of making sure that you kind of estimated that and recorded it. And then what are you recording exactly is your own visual impression of what happened. So what would happen is people would be looking the eyepiece, you'd have a tape recorder going, you'd have a shortwave radio going, you'd be looking the eyepiece, you'd yell out, and then you go back, and that would be your recording. And then you'd say, yes, I saw it, and you'd be really happy about it. But then you'd have to go back on that tape recording and go back and forth and try to get that timing just right. So this was also, again, a source of potential error, particularly because everyone has a personal equation. How many people here know their personal equation? One person. Very good. Well, that's actually more than I thought. So a personal equation was essentially your estimate of your reaction time, because nobody's reaction is perfect. So you see this thing go out, and it's all very exciting. And then people go, oh, oh, out, right? And it's like, well, that kind of thing is going to put you off by half a second, three-quarters of a second. And the timing is very important. So you're trying to get it as accurate as possible. And so there were actually rehearsal things you could do and practice on to determine what your average delay between the time you saw something and the time you yelled about it was. And everyone would say, well, my personal equation is 0.2 seconds or 0.25 seconds or something like that. So this was all part of it, right? So you would rehearse and you would estimate and you would try to figure all of that out. So all of these things basically added up to a lot of sources of error: the map locations, the timing, the recordings. The other limitation was predictions. So we have to know when to look at what in order to see anything, right? So one limitation there was the accuracy of star catalogs. So star catalogs have improved enormously in the past 20, 25 years. We used to have the Tycho catalog, which would kind of tell you the star is kind of around here somewhere, over roughly there. And then you'd say, well, the asteroid's going to be in the neighborhood. So then the chances of this star over here actually meeting that asteroid over there would be hard to manage. And now we can constrain that messy area where we think the star is right down to a very, very small area. It's much more accurate. Similarly, asteroids are much more accurately known now. So we're able to get much better accuracy on our predictions, and a lot more predictions. We're able to find more events. And back in the day, only very large asteroids like Ceres and Vesta could really be tracked well, because they would be big enough to cover the star kind of no matter what. So, essentially the bottom line here is that we would end up with lots of, error bars. So scientifically, yeah, we know something happened. We know approximately when it happened, and we know approximately how big it was. All of these approximations would add on top of each other, and in the end, you'd end up with something. The good news is, like, some information is better than no information, right? So that's how science moves forward. We gather what we can with what we've got, and then we look at the problem. We say, well, gee, we could do better. And yes, we can do much better nowadays. So let's talk about occultations now. So one of the most important things has been communication. So the internet has, of course, allowed for enormous amounts of collaboration and data sharing. And occultation feeds now are being generated by various astronomical data sources, observatories, and observing programs that are pulled together and give you probabilities, expected durations, magnitude drop that you can expect to see, what the star map is exactly, and where to find the target star and everything. And interested observers are able to participate through Occult Watcher software, which I'll show you in a minute. In terms of recording, now we have astronomical video cameras. They've got high sensitivity. The frame rates are pretty predictable, and we're able now to precisely, as I kind of showed on that other picture with the drop in the star's light output, precisely identify the when of the outs and the ins for the occultation, down to the limit of whatever that camera system is. And when you're looking at occultations, it's a system combination. It's the camera plus the telescope. So the bigger the telescope, the deeper you can go with to find stars. The smaller the telescope, the shallower you're going to go. And of course, one of the other things about having a recording is that you can actually confirm with confidence that you were actually looking at the right star. Now, I'm not mentioning any names, but it is possible that some astronomers that I know personally have spent a whole night watching the wrong star to see if it disappeared, and were unsuccessful at their occultation. I'm not naming any names. But anyway, we'll carry on. And then the other thing that's nice about this is that visually you needed a really distinct drop in brightness in order to really know that you saw the thing. right? But photographically or video wise, you can see a subtle change in that. So the example is, I have an asteroid at 9th magnitude. I have a star at 9.2 magnitude. So when that asteroid gets in the way there, I'm going to lose 10 or 15% of the light output. Probably not enough to notice visually, but on a camera, I can see that drop off. I can see I'm still seeing the asteroid, because sometimes the asteroids can be bright. Sometimes they're dim little things at 14th or 15th magnitude. And basically you don't see the asteroid at all. You just see the star disappear. But sometimes they can be very close. And that's where the recording technology comes in and really helps. Of course, location, well, all of that map work and all of that details, that's gone out the window now. GPS tells us down to within 20 feet, 10 feet, exactly where we were standing when the occultation happened. And also the timing of GPS allows us to be down to a fraction of a second. So you can have a GPS not only tells you where you are, but it also tells you exactly when you are. And so you put that information together, you connect that GPS to the video, and a lot of times what we have there is essentially a video overlay where we put the timestamp on each frame that's coming out of the camera. So when that frame shows us that that light drop has happened, we can read it right off the screen. Oh, that happened at 10:52, 49.21 p.m., right? And that becomes part of our data reporting there. And so there's two versions of this. One is sort of an analog camera where we're overlaying the timestamp. And then you can also get digital cameras which actually directly insert it, but they're functionally the same, right? And then the other thing, of course, is the collaboration piece. So the software that we've been using for most of my adventure with occultations is called Occult Watcher. So it's Windows only software, so that's limited some people who are Windows challenged. There are some of them out there, but it has over 2,500 collaborators around the world. And essentially the process is you enter your sites, and you say, here's where I might want to go to observe occultations. You can get a set of predictions for that location, and you review the ones that you want. And if you think you've got one that makes sense for you, and I'm usually looking for something that's not too early in the morning, it's got a reasonably bright star, it's got to be kind of 30 degrees up or more, because I live downtown and I need at least 30 degrees to get over all the muck. I can register for that event and tell everyone in the world that I am registered for it. So if we take a look at that, where is it? Hello. It disappeared on me. Don't do that. There we go. So this is Occult Watcher, the software here. And you can see here that I've registered for, whoops, wrong. Stop that. Thank you. Must stop presentation. End slideshow. There we go. Okay. Sorry about that. There we go. Now we can see it. Okay. It's a little hard to see, but I'll see. I can't embiggen this anymore. But essentially what we're seeing here is a list of events with various things about it. Probability of the event is interesting. So a high probability means that there's definitely going to be something. And here is an example of an old asteroid 640, Brambalea. And you can see here in the bottom, this is the projected shadow path. It's the blue is the high quality projection, and it's got a little bit of pink around it, which means that's the uncertainty. So we really know a lot about this asteroid. We know its size. We know almost exactly where it's going to be. And my location is right here, this black spot. So I can see how other observers are set up. So we've got Drago over here, and we've got myself over there. So two people have signed up for this occultation, which is going to happen at 4:51 up to 3 seconds. It's going to be a significant drop in magnitude in the constellation Aquarius, southeast 31 degrees. So this is a good one, and it's expected this weekend on Sunday, May 11th. We have another one, which is a very different kind of occultation here. Here we've got an asteroid number 397,718. That is a very recently discovered asteroid found in 2008, and it's a small space rock. And so you see here with the pink at the bottom there, it's got a lot more uncertainty. We don't really know for sure where this one is. We think it's going to be here in the middle, but it really could be anywhere in this pink zone, right? So unlike our big asteroid 640, this one is a real mystery box. And if I were to go ahead and try and see it, my estimated probability of seeing it from my location is about 3.2%. If I do see it, though, we would nail exactly where that asteroid is and significantly constrain its orbit characteristics and so forth. So it's kind of useful, but you get a lot of this information here. And what the cool part of this, of course, is the collaboration. So I'm registered here, and on the observation plan here, there's 2,513 users, 1,000 events that have been coordinated, 9,000 stations, all of whom, to one degree or another, are participating in this process. And if they get a hit, you submit it to the central clearinghouse. And if they find out something interesting about your asteroid, your name will be included on the paper that goes with that interesting asteroid. So this tool has been in use for about 15 years, and this is what I would almost call, it's still very useful now, but it's not necessarily the state of the art. Am I seeing again? Okay, hang on a sec. And I want to go to, we'll get there fast. I know there's a get there fast button, but we'll just go ahead. All right. So we just had a quick look at Occult Watcher. So now there's a new and improved version called OW Cloud. So this is a cloud-based application which is also come from our friend Hristo Pavlov. And this man, I believe he lives in the Philippines, Southeast Asia somewhere. He is just making this amazing software just for fun and profit and to help people out. There is no profit in it, I should say. But essentially, this is consolidating all of the predictions, and it includes a built-in search tool to help you find occultation opportunities. And it gives you all kinds of interesting information. So if we compare what I just showed you with Occult Watcher here, so this is essentially the search feature. And again, I got to stop the presentation. Yes, thank you. All right. Stop the slideshow. There we go. All right, back to my browser. There we are. So, so I have my own login, and this login is actually connected to Occult Watcher. And if I go to the search here, I can basically have a set of filters where I have my favorite locations here. So I've got the Carr Observatory, I've got the Carswell Observatory, which is the observatory right up here, and I've got my own home included as locations. And what I can do here is I can pick a date, I can pick how far ahead to search, and I can go and look for occultation opportunities that might be there. And I can see here we've got some interesting ones. So there's the Brambilla one that we were just talking about. And I can see that Brambilla is going to go over this observatory as well. And I get a lot of useful information. So it's a 10th magnitude star, so that's pretty reachable by a small telescope. 4.2 magnitude drop, it should disappear up to 3 seconds, 100% probability. And I can go in here and I can look at the location here, and I can zoom right in, and I can see exactly what the predicted path is over the city of Toronto. So I can actually go straight in here, and I can go in more depth, and I can, whoops, that's the wrong plus button. Thank you. So here I can see, I can actually go on here and I can mark. I can go right down to the Carswell Observatory, and I could mark my location as a participant for that location. So anyone here who has a telescope and is interested in trying this out can go on this website, set up a little search profile for your favorite location, and see if you've got any occultations coming up soon. It's much easier than working with Occult Watcher, but it's all driven off of the same database and the same capabilities that are there. And then once you pick your option here, so let's take a look at this Brambilla one here. You can now go into events and look at a specific event. And you can drill right in. Oops, so let's go and find Brambilla here. All right, search. Should be there. Okay, it's a little flaky for some reason. Come on. All right, I'm going to go at this. I know there's another way to get here, but I'm having trouble executing it. So what I'm going to do here is I'm going to go through the other path, which is to use the old software and view details on the web. So I've got the option here to go view details on the web, which should take me right there. And there it is. Okay, so I have all the information now about this occultation of Brambilla. And here you can see a sort of a cosmos eye view of this occultation. So here's my station in Toronto, and here's the predicted path. I can see the same kind of information I saw in Occult Watcher here. I've got lots more information here about the details of this and different information about the path and everything here. So I'm able to put that whole package together and find out a lot more about this particular event. The other thing that's really cool here is I've got Finder chart, so I can have a look and preview what this star is going to look like. So I can see, oh, look, there's a couple of really bright stars and 3 bright stars in a row just outside here. So finding this should be a snap if I wanted to find this occultation. So it's going to occultate that star. So I got to find 3 stars in a row, little hockey stick thing here, and it's going to be hanging off there. So all of that information is online, and it's freely available to us all. All right. So I'm just going to stick here because that will make it better. So we talked a bit about Occult Watcher now, OW Cloud, I should say, and what in order to observe it with the latest technology, you need a telescope. It can be as little as 90 or 80 millimeters. It doesn't matter, as long it just controls how deep you can go and what events you would be able to get at. There are analog camera systems, a little old school, but they work just fine. IOTA, an organization I'll talk about in a minute, they're offering them for about $425 US. And there are also GPS-enabled cameras that do that timestamp, excuse me, I was talking about earlier, available from specialists. And then the newest and coolest is an integrated system called Astrid, which is using Raspberry Pi. So just for the benefit of the audience, I'm holding up the Astrid camera here. And this is a complete system which is designed to work with any telescope, especially a computer-driven telescope. So at the front end here, we have the eyepiece. So you put this is the end you put in the telescope. And then it has its own Wi-Fi network. It does plate solving, so it will take you to the correct location. So you load in your occultation event, the one that you want to go see, and if you've got a go-to telescope, it will take you there. If you don't have a go-to telescope, it will take pictures of where you're looking, plate solve it for you, and tell you whether you should move your telescope this way or that way to get on target, and it will let you know the target that's there. It does the video recording for you, manual or automatic, so you can essentially watch it and keep an eye on it and do the recording by yourself, or you can set it to go overnight. So you can say start at 2:38 in the morning and finish at 2:42 in the morning, and let me know how it turns out when I wake up in the morning, which is a really, really great feature. You're able to import the data to this camera from Occult Watcher, so that all of the details that you need are already available, and that's really, really key. So I'll just show you a quick glimpse of what it looks like when you're driving your telescope, and then we'll be I'm just going to switch here from my current Wi-Fi connection to the Astrid camera. So I'm switching my Wi-Fi because it's broadcasting its own Wi-Fi on its own network. And so I switch over to that camera. And then I'm using free remote PC software called Real VNC. I have this set up here, and it says no such host as no. Come on, you surely know. Yes, you know that host. So I can see it's broadcasting, so it connects. And here is the desktop. So I'm running a whole little PC on Raspberry Pi here, and the Astrid app is right there, and I can pull it up. Now, it's all in red night mode here, but you can see that I have occultations, and the key thing here is to get all 4 of these boxes in green, which means that you've got everything ready and set for your event. So the first thing is your site information. So the GPS needs to be connected and know where you are and download the exact location of where you're at. The GPS needs to be running and recording the time so that it can date stamp it on the camera. And once all of those things are in place, then you are ready to start observing. And you can set up various things here. There's a feature called exposure analysis, which will tell you, are you going to be able to see the target star, and allow you to adjust your gain and other video parameters to make sure that you can see it. You can control your mount, you can park your mount, and you're able to do the video recording and everything. So essentially, it's taking care of everything. It's driving your mount, it's taking care of the video recording, it's got a sensitive camera built in, 12 volts. It's impossible now to make a mistake when you are observing an occultation, unless, of course, you get the date wrong and you set it up to record an occultation one day after it happened. That is still, thus it is still possible to screw up an occultation, even with the best possible technique and technology that is available today. And I am proof that it is possible. So the only comment I'll have on it is that it is it's a Linux application. You can see here it's kind of a little. He's done a lot of work, and it's just coming to us from a fellow named Mark Simpson out of the Calgary Center, RESC Calgary. So he's done a great job here of trying to put this together in a way that is simple. It's designed to run on tablets or phones, so you can actually drive this from a tablet or a phone. You don't actually need a computer, but it is a little finicky, and you got to be kind of comfortable with the fact that you're running Linux here, and it will work well for most practical purposes as long as you follow the instructions. And it's kind of like every piece of astronomical equipment I've ever seen in that way. So getting back finally to the end of the presentation. So occultations have come a long way since we first began. I think the first occultation was confirmed in 1623, and that was an occultation of Spica by the moon. And so we have been doing a lot more in this area since IOTA became an organization back in 1975, and it's been continuing to grow over time, and it continues to be an interesting and exciting part of the hobby. And certainly, if any of you have any questions or would like to talk to me after the presentation, I'd be happy to review that. I would also encourage anybody who's interested to get involved. Occultations.org is the website of the International Occultation Timing Association, or IOTA. And also bookmark that website, cloud.occultations.net. Put in your parameters and put in your coordinates and see if you've got anything coming up. Like I say, even if you don't want to get into the business of recording an occultation, wouldn't it be cool to see a star disappear for 4.3 seconds, just exactly when it's supposed to? And get more involved if you're interested. We'd love to help you out. And I know there are other folks in the club that would love to help you out with this as well. And that's it for me. Thank you very much.
Thank you very much, Dennis. I'm going to start off by asking my own personal question.
Sure.
Astrid is, I assume, as any good piece of astronomy equipment, is supposed to be almost waterproof because the amount of dew you will end up with at about in the early morning hours in September in this part of the world.
I don't know that answer for sure. It would be a good question to ask on the forum. I would probably put a plastic bag around it.
Okay.
But it has ventilation, and I think they're more worried about keeping the chip cool than they are about keeping moisture out.
Okay.
But the camera compartment is well sealed.
And how well does she handle in January at about -25?
I can't answer that, but we'll find out, I suppose.
Any other questions from the room?
Yeah, I've got to ask, how much is an Astrid camera?
It was about $700 US.
Okay.
And Mark has a video online where he's actually he has put together a contraption to assemble the circuit boards himself, which I was very, very impressed by.
Okay, and does it have a built-in GPS, or are you slurping it in from your phone?
Nope, built-in GPS. The GPS antenna goes right there, and it like I say, it complains if it doesn't find your GPS. And this GPS actually, when I tested it, I got a perfect GPS signal in 2 seconds, unlike my other GPS camera, which is much more finicky. So,
cool. Thanks.
Yeah.
All right. And no one else. Any questions online?
Yes. This is a question from Zapfan from Sweden. He asked, have you watched any Kuiper belt objects?
Well, one of the things that I think I have not personally, is to answer the question directly, but I think one of the applications for this, of course, is Kuiper belt objects are generally not well known. We classified as trans-Neptunian objects, TNOs. So those occultations will be very low probability. The shadow may or may not hit the Earth, and we don't even know exactly where on Earth it'll hit. But if you can nail it down and constrain that object, you would get it to work. And it should also be a relatively very slow occultation. So it should take 10 or 20 or 30 seconds because those objects are moving very slowly. So that's one of the reasons why there was a real push on to get more information from occultations for the Pluto probe, which was called New Horizons. And so this was actually one of the things they did, was they actually looked for an occultation which went across South America to constrain the location of the target asteroid for New Horizons. And that was part of their planning. Before they were able to actually see the asteroid, they were able to determine exactly where it was and refine its orbit through occultations.
Okay, Denis, once again.
One more question here.
Hi, thank you very much for a nice presentation. Just wanted to ask you maybe a stupid question, that meteor shower can cause occultation?
A meteor shower would, I suppose, in a very instantaneous sense, yeah, you could have a meteor on its way to Earth, like before it hit the atmosphere, could blink in front of a star, but you'd be hard pressed to tell that event from a high flying bird, which could also blink out a star as well, or even like an aircraft that's not, got its lights on or whatever. So yeah, it could, but it would be, but that's not, of course, what we're really interested in, but it's possible, I guess. Yeah.
Although on that note, there have been some rather famous astrophotos in which a shooting star happens to pass through while someone is taking the photo.
Yeah, photo bombing by meteor debris. Yes.
All right, Denis, thank you once again.
Okay.
And we're going to go back to fun facts while we set up for our last presentation of the evening. All right, and we're back. And our final speaker of the evening is Ed Trejis with his talk, I Want to Be Left in the Dark. Ed?
Thank you, Tom. So that is, in fact, the title, and a lot of astronomers, sorry, I have a bit of a cold. I'll try to talk through it. Do like to be in the dark. So a frequently asked question that I get asked, and I do host star parties down at Long Branch, is where can I go to get a dark sky? I mean, this is often asked at star parties where we're still in the city of Toronto. So would it be any place recommended on social media? Should you go to blog.to and see that, hey, the Torrance Barrens is a wonderful site? I have never been there, and I don't plan to go there because I imagine every influencer is like taking selfies with lights and stuff, and it's going to be pretty annoying. And also, there's a question of, I'd like to get darker skies, but I don't really have access to my own car. So it's a little bit tricky to answer this question, and the idea of this presentation is, I don't think I'll die, is to give some things to think about. I don't have a definite answer, but I've got some suggestions and some tools that you might want to use. So the Toronto Centre of the RASC does hold city star parties, so you can get to those without having to drive a car. They're held within the city and they're accessible by transit, and people have come to our star parties by transit. There's a regular star party at Bayview Village Park, which is on Bayview Avenue, just north of Shepherd, so kind of in the North York area. And we have a new star party at Long Branch Park. And for the people who look at a Queen car and say, where the heck is Long Branch? It's kind of, you go south on the 427 or Kipling Avenue, and you keep going south until you hit the lake, and that's about where you are, south of Lakeshore. It's around on the waterfront by Long Branch Avenue. So here's where we go to our first little website, and just for people who are looking, who are stuck in the city, here's something that you might want to look at. So we're going to go to a nice browser here. We'll get, oh, well, I was just going to replace that URL. Well, goodbye to the ad block. So if you type in, oh, what is this doing? Pretty easy URL to remember. And it thinks about it. Hopefully it gets somewhere. So you can see the URL changes a little bit, but I'm not going to try to memorize that. View Toronto maps. So these maps actually can do a whole bunch of things. If you're looking to see whose property line is where, this stuff is all on there. This is GIS, Geographic Information System, but what we are specifically interested in is the image gallery. So what we have in the image gallery is a nighttime view of the city of Toronto, and we can zoom in nicely, and you can see, whoops, wrong way. You can see what the city of Toronto looks like at night, which is interesting. You see all these bright areas, which are actually industrial areas generally, or warehouses or parking lots, and they're awfully bright. I wouldn't recommend trying to do any observing there. Let's just pop up here. Where's York University? York University is going to be... The one thing with this map is it's actually a pain to go to, try to hop over to, so that's got to be Highway 400. That's Jane and Finch. So I guess York University is here. Yeah, it's pretty bright if I've got it right. In any case, the residential areas of Toronto are darker, which is nice. Yeah, so like I say, the problem here is the switch between an actual city of Toronto topographic to find out where you are and switch back and forth is a little cumbersome on this. The interface isn't the greatest. So that our Bayview Village Star Party is, there's the 401, there's Leslie Street, there's Bayview Avenue, it's somewhere up here. There it is, Bayview Village Park. So if we go back to our images and we pull up the nighttime image, it's fairly dark in the area. It's a treed residential neighborhood. The one thing that is a little bit tricky is it is not much north of the 401, which is, I believe, this guy along here. Oh, sorry, is it that one? Oh, further south? Right. There it is. So you can see that all these high mast lights are kind of orange. Now, I haven't been to Bayview Village recently. It's out of my way. I'm closer to Long Branch Park. But the MTO is replacing all the high mast lights on the 401 from the high pressure sodium to LED lights. And the LED lights, that's Shepherd? Oh, yes, yes. There we go. So the old lighting on the 401 is actually fairly dark, but the lighting is getting a lot brighter from my judgment, and I'm pretty sure those masts are going to come south of there. Hopefully it doesn't make a mess of the observing at Bayview Village Park, because they are quite bright and quite white. The other place that we have our observing, as I say, is Long Branch. This is Humber Bay for those who kind of, Parkside is down here, High Park is here, and our park is down here. So we're actually looking south over the city. Sorry, we're looking south over the lake. So it's fairly dark. We are actually on the lake shore. So everything south of us until we hit St. Catharines or Beamsville or whatever it is on the far side of the lake is dark. So that's helpful, even though we still have the glow from behind us, from all the city and the warehouses and everything. So we're going to go back to the presentation. So that's the sort of problem that you're going to get in with our star party. So like I say, always new challenges. High mast lights are being relamped to LED. They sure look like brighter to me. That's only 1 kilometer to the south. And in fact, there's a redevelopment proposal happening just north of our Long Branch star party location. It's all in the residents going take. We'll observe there in the meantime. Another useful website that I use for light pollution mapping, and there are probably multiple, and this is just the one I happen to get myself familiar with, and as far as I'm concerned, it's good enough for government work, is cleardarksky.com. Which does a number of things. It also does very detailed astronomy forecasts for whatever area you choose, but for the purposes of this talk, I'm going to pull up the light pollution map. There it is. You can see dark is good and bright is not so good. So we can zoom in on Toronto and we can see Toronto is very not good. There's Toronto, it's kind of whitish, and if we go down, there's the scale down here, and we are like, there's a scale called the Bortle scale, and I guess it was named after someone whose last name was Bortle, but I haven't done the research for that. The numbers, a lower Bortle number makes the sky darker, and a higher Bortle number makes the sky really not dark, and Toronto could be Bortle 8 or 9, and that's just not very good. Oops. So the one thing that I will note with this website is you can actually scroll this, so that way you can really tell which intensity it is, because sometimes I have a trouble telling a dark blue from a light blue. And if you scroll the other way, you can actually get down to the underlying map. And if we go back into Toronto, so this is kind of your city of Toronto, and we'll just intensify the map a little bit. You can see we're in an awful lot of like horrible white. That's not what we want. But if we look over towards this area, which is the very end of Scarborough, if people are familiar where the zoo is, this is the zoo somewhere up here off of Meadowvale Avenue. It actually looks a little bit darker. So my guess, you can see we're actually into still not good. Red is not good, but it's better than sheer white. And that is just in the shores of Lake Ontario, right by the Rouge River. And again, you can play around with this. That's about as best as you'll do in the city of Toronto, and that's accessible by transit. So if we go here, go east, and I realize I'm saying this at York University, and Rouge Hill is kind of like right across the opposite side of the city. Southeast and northeast Scarborough might actually like be Bortle 7 instead of Bortle 1 billion. Northeast is TRCA and Rouge National Park. If you've never been there, it looks like you're out in the country. They're open fields, but you need transportation because the buses don't go there. The roads are unlit, but they're narrow and there are no sidewalks. So do you want to be walking there at night and get run over? Probably not. Southeast is on the lakeshore, east of Rouge Hill GO Station, easy go and TTC access and parking. So if someone is really kind of curious and they live out in towards Scarborough, they might want to try going to the lakeshore south of the railway tracks, either along the Rouge River or through Port Union Park, and see what they can see. It's the opposite side of the city for me as well. Maybe I'll just catch the GO train out there one day and have a look. But that's kind of as promising as it gets in the city, with not requiring car access. Okay, so let's get out of the city. We'll borrow a car. We'll get a car share. We'll do something. I have not been to Torrance Barrens, but I've certainly heard stories. There are a couple of maybe more obscure dark sky locations. I don't think they've been on BlogTO. There's Lennox Addington and Frontenac. Both of them are a considerable way east of Toronto, like you go over towards Napanee or something and you go north. It's been a while since I've been to either of those. There's links to them. Once this presentation is online, you can go and check out the links. To be honest, I think that the Lennox Addington one, which is further south and more accessible, still gets pretty busy, because when I was there in like pre-COVID times, there were still people trying to do atmospheric night shots. So they're lighting up the barn that's in the distance to have the star trails over top of it. And it's pretty annoying if what you want to do is look up in the dark sky in a dark environment. So the Frontenac site is a long ways from anywhere, and you probably won't get bombed by influencers or anything, but it is a long way from anywhere. It's probably a 4-hour drive from Toronto, and that's starting from kind of the east side of Toronto, probably. And there's actually another question here, which is darkness everything? So I'm going to compare 3 locations where I've been to observe in a reasonably dark sky, hopefully, and give some other reasons or some other considerations that you want to make when you're planning where you want to go. And the spoiler is, dark is great, but there can be other considerations. So case 1 is the Carr Astronomical Observatory, which is the Toronto Centre's very own observatory. And it's up on Blue Mountain. You'll see on the map in a second. Let's look at the advantages and the challenges as a dark sky site. So first challenge is pretty obvious if you've ever been there. It's not super duper 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 dark, unfortunately. We'll just pop over to our light pollution map. It's always easier to find stuff when you're not trying to do a presentation. Let's zoom out a little bit. So it's up towards Collingwood, and I should be able to. Left? Is that my left or your left? I'm going, yeah. Okay, it's here about somewhere. We don't have to get it exactly. And if we scroll into light pollution, you can see that it's kind of in the starting to be dark orange or green area. It's in here somewhere. Trust me on this one. I'm not going to try to fiddle around with it for a while, but I've done that very carefully when I'm not actually standing up and trying to talk to people. And that's about where it is. And the orange and green is kind of in here. So it's like Bortle 4, Bortle 4.5, not super duper dark. And a lot of that problem is Collingwood. Collingwood keeps growing, and they keep building more condos and village complexes, and they light the ski hills in the winter, and well, there you go. Development in Collingwood and new proposals in the south aren't really helping. You need transportation, minimum 2-hour trip from Toronto. That's from where I am with my own car. It can be tricky to get there in winter or stay there in winter if the blizzard suddenly blows up, but this is actually the first year that we have winter access. So that's something that people might want to check out. Just keep in mind, if there's a huge blizzard, you might get stuck there no matter what we try to do. But there are advantages, and this is the point, is you can't just say it's too dark or it's not dark enough. I'm not going to go there. There is now road access in winter. There's a observatory set up for imaging, which is you're capturing it on whatever camera you bring, and it's a complete observatory. You just bring your camera, you bring your software, and off you go. It's got you use your own observatory, set up your telescope in this sheltered thing with a turning roof and stuff. There's a supervised observatory with quite a big telescope. I imagine it's kind of in the range of what you have here in the Carswell Observatory, maybe not quite as fancy, but still a pretty powerful telescope. There's an observing pad, and there are all the comforts of home, because it is a home. It's a 3-bedroom house. It's got electricity, running water, Wi-Fi, kitchen, bedroom, showers, you name it. So CAA visitors also, unlike these public dark sky spots, are generally compliant with dark sky etiquette. So, if someone accidentally flashes their car lights, they're going to be very apologetic instead of saying, hey, what are you complaining about? And they'll hopefully won't do it again. So even though it isn't super dark, you can go up there. It's a location that understands what you're up to. You're not like some strange person there. Okay, case 2 is Pelee Island, which is an interesting one. It's an island in Lake Erie. I decided what's a clean shirt I have, and I wore my Pelee Island shirt. It's not a designated dark sky site, unlike Point Pelee, which actually is, and that's the national park south of Leamington that sticks out into Lake Erie. But again, challenges, it's not that dark. And let me just show you where Pelee Island is on our friendly map here of light pollution. So we zoom out, I run down the intensity. Now it's again a pretty good trip. You're not going to get there by Uber. It'll cost you a fortune. So there's Lake Erie, there's Leamington, and there's Pelee Island. And you get there by ferry. You do not drive there. And if we do the light pollution map, it's not that great either. It's kind of in this orange zone, so it may even be a little bit brighter than the CAO. So it's not that dark. It does not specialize in being a dark sky site particularly. And you need transportation, minimum 3-hour trip from Toronto, plus a 90-minute ferry ride. But again, there are advantages there, and I've been there, and I can say this. It's locally quite dark apart from certain locations like the ferry dock. It's like a whole bunch of big farms, and there's like grapevines growing there for Pelee Island wines and soybeans and farming stuff, but basically there aren't a billion streetlights. There aren't a billion industrial warehouses with bright lit parking lots. There are very few lights. The big light dome from Windsor or Detroit is to the northwest and can be somewhat ignored. The light domes to the south are not too bad. It's nice and level. It's flat island. It was half of it was swamp, and they have to drain it with pumping to keep it from turning into marsh again. Lots of publicly accessible areas, Conservation Canada and conservation sites that are publicly accessible. No one's going to bother you. That's where you can set up your equipment. You can get from anywhere to anywhere in a jiffy. It's not that big. It's not that busy. And it's a quiet and relaxing place to visit and hang out. So my chosen location, it's kind of hard to tell. This is on the east side. This is all one big conservation, I think that Nature Conservancy Canada area. And there's a small parking lot there. And the times I've been there, I am the only car that ever pulls in there, and it's a big restoration meadow. It might become a little bit more grown over, but right now it's a large open area. There's trees like only very far away in every direction. So you probably have less than 5 degrees obscured, which is pretty good, because another consideration is if it's dark but there are trees overhead, it's not going to do you much good for astronomy. Local lights show up poorly on large-scale light pollution maps. So this is something called nightearth.com. I'm not going to start that up because it's kind of a resource-intensive website. But this shows like what the lights actually are individually instead of a light pollution map. Over here is the ferry docks. This is Scudder, which is the only settlement worth noting. And I'm over here, so there's like basically, there's one farmhouse light to the north of me, and there's one radio tower red light to the north of me, and that's it. I see no other local lights. Everything else is dark. So the other thing is the Pelee Island location, which is another thing to think about. Pelee Island is about as far south as you can reasonably go in Canada and set up a telescope. Any further south, and not much further south you can go, you'll be setting up on a boat. It's a little south of 42 degrees, or almost 2 degrees south of Toronto, and objects in the south sky are just that little bit higher. And for instance, the center of the galaxy, which is in the constellation Sagittarius, and it never gets that far above our horizon because it's in the southern sky. And what I've done is, so this is what you kind of see from Pelee Island in theory. This is not a picture I took, this is from Stellarium. It's just to illustrate what's going on. And over here is Scorpius. You can see the tail of Scorpius and Sagittarius. So this is what you'd see. If you go to the CAO is north of Toronto, and you can see how the stuff at the very south is dropping down. And that's not a time lapse or anything. That's simply because you're going further north and the stuff in the southern sky is getting lower. And for the other place I'm going to cover, which is Manitoulin Island, it's even further north. It's north of the Bruce Peninsula. And you can see you'll never see the bottom of the tail of Scorpius. It goes down here, and then it's like somewhere under there. And the question is, how much is that worth to you? 2 degrees is not very much. My understanding is that there are ambitious astronomers from Windsor Center who go and try to see the globular cluster Omega Centauri from Point Pelee. I think it comes up over the horizon by half a degree or something. Right, but like you're not going to be observing it. Let's be honest. This is a parlor trick, right? You go and say, I observed Omega Centauri, but you're not really observing. You're just kind of spotting it or thinking you spotted it and saying, this is good. Let's go for a beer. Okay, so case 3 is Manitoulin Eco Park. It's a dark sky area, and they actually explicitly have a dark sky area. They have a website. It is, not surprisingly, on Manitoulin Island, which is the island kind of north of the Bruce Peninsula and southwest of here. Let's just pull up the map. So we're done with Pelee Island. It's kind of an island, and we're going way north. Yes, what? Why are you doing this? Seems sticky. Right, there's the Bruce Peninsula, there's Manitoulin Island, and the Eco Park is somewhere hereabouts. And if we scroll over and see how dark it is, now we're talking dark, right? So this isn't the darkest dark in Bortle, because there are 3 shades of black, but it is pretty good, right? So we're probably in this Bortle 2, and the other one is also Bortle 2, and then there's a super black Bortle 1, which you won't find anywhere close to civilization. So challenges, it can get busy on, the dark sky protocols are not followed. I was there this last year at the Labor Day weekend, and there were people who were opening and closing the rear hatch of their SUV, and every time that happens, the lights all flash and light up everything. It was pretty annoying. There are lots of trees around the dark sky that can block views, so you can move around and find a good spot for what you want to watch. But just to see the whole sky, oh, well, that tree's in the way, so I'm going to move over here, but now that part of the sky is blocked. It's a many-hour trip, whether by ferry from Tobermory or by car driving up to Sudbury. It's like 6 or 7 hours easy. And their fees are increasing. In fact, it was to stay in their stargazing cabin, which does not have electricity, does not have running water, costs more than my stay in a cottage on Pelee Island that had a fridge and a stove and Wi-Fi and everything. So I may not be back there this year, but it was pretty good. There are big advantages to go there, though. It is dark. Jupiter can be annoyingly bright. Jupiter's been out these past few years. When I've been there, it's like, can someone turn that planet off? It's a big enough field that you can usually find a good observing location for what you want to view. It's nice and quiet when it's not busy. So after Labor Day weekend, when people go away midweek, you're probably good. Stargazing cabin makes decent accommodations, even though it's expensive and doesn't have facilities. You could spend a week there, and I have. And Manitoulin Island, like Pelee Island, is another nice getaway. Lots to see and do on a daytime. So in conclusion, you can observe in dark skies or darker skies than you'd have in the city. You will have to travel outside the greater Toronto and Hamilton area to get into anything halfway decently dark. Beware of social media. If they say go here, you probably don't want to. I mean, you can try it out and tell me what happens. Light pollution maps are helpful, but actual observing location and conditions make a real difference. So in Pelee Island, there's a big light dome to the northwest where Windsor and Detroit are. It's huge. Like any clouds over there are almost blindingly bright. If everything got shifted around somewhat, those light domes, you'd still have the same light pollution intensity according to the map, because you aren't adding or taking away any light. But if that light dome was due south, it wouldn't be useful to go there to see the southern sky, because it would all be washed out. So the fact that the light dome is somewhere where you're probably not wanting to look makes it better than its darkness class might indicate. Whereas you look about ready for me to wrap up. In conclusion, there is one other place that I actually checked out recently, since I wrote this sucker up. This was going to be presented a month ago, but we had some weather issues. So I'm going to unzoom this. Just to give you an illustration of my point, is if you go over, this is Prince Edward County over there, which is a nice rural area. Maybe people have heard of it or been there. And if we look at the very south end of Prince Edward County, it's in a fairly dark area. So I said, I'm going to go there and see what the skies are like. So I drove down there, and it's like another almost 3-hour drive. I drove down to almost Point Petrie, which is over there. You might have heard that on like marine forecasts. And it turns out, first of all, there's a lot of light to the south. I don't know where the heck it's coming from, because to the south is a lake, but up to like 15 or 20 degrees, there's a band of light as if there was aurora. So there was no Milky Way overhead to really compare, because as the sky this month might have said, the galactic North Pole is almost overhead, so the Milky Way is pretty much on the horizon. The constellation Hydra, I could kind of see most of it. I could see the constellation Corvus, the crow, which sits on Hydra, but there's a dimmer constellation called Crater, which is supposed to be the cup, and I could barely see it, and it's just pretty disappointing. I can't see it from Toronto, where I am, by Long Branch, but I don't expect to. And the other thing is, there were frogs going in every direction for kilometers, which is all very nice, but that means it's all boggy, which in fact it is. Now, the bugs weren't out a couple of weeks ago, but I imagine June, July, August, September, you can get bitten to death, and I wouldn't even go there. Like, you will die. So basically, in conclusion, while these maps are helpful, you actually have to go there and take a look and say, this works for me, or let's try someplace else. Do plan ahead, research, get people's opinions, but only a visit by you yourself with the equipment and the sort of observing you want to do will really tell you if this is a good dark sky location for you or not. And that is the conclusion.
Thank you very much, Ed. Any questions from the audience?
Hi. Amazing presentation. This was super useful. So I'm just starting out myself. Last year, my friends and I we went to Algonquin Park.
Okay.
And yeah, that was, I think on that scale was one of the really dark gray ones. A lot of
Yes.
success there, right? It's also
Yes.
a 3-hour drive.
Yes.
What do you think about that? I think that was a great spot for me.
Algonquin Park can be great. And in fact, we have the Toronto Centre has an annual Algonquin Adventure, which is happening this year in September. The things to think about with campgrounds is if you're in a campground, that may not be the ideal place to set up a telescope for a couple of reasons. You might have neighbors who like to play with their lights and have like 10 lights on, and campfires aren't really very good because if the air is still, the smoke goes up and it gets very hazy and that blocks your view. I know that in Algonquin Park, the adventure is on Mew Lake, so you're trying to look south over the lake, I believe. I've not actually been. I hope to go there but yes, like once you get that far north, a provincial park is a good place to visit, but beware the crowds and beware other people close by. But yes, if you can find and this is kind of the problem is you can say this area is dark, but you get there and you go, where am I going to set up a telescope? There are trees everywhere, and if I don't set up in trees, I'm setting up by the side of a busy highway. Like you have to go there. And the other thing I would say is you never go up and look for a dark sky site at night because you won't see it. You have to go up there during the day and pick out, a few good, if anyone's ever done car camping, like I'm on a road trip and I just want to pitch my tent up by the road, which I've done, you will never find a good campsite at night because you don't see them. And the same thing will happen with, in the daytime, you might say that field is pretty good. I see a road going in there. At night, good luck. Hopefully that kind of answers your question. Mm-hmm.
Anyone else?
Thank you very much. It was very useful. I think I know a place in Oxbridge called Glen
Major.
Park, Glen,
Yep.
which is not a very popular place, but it's pretty dark.
Yes.
And the parking is open.
Well, so we actually had events. I don't know, and Tom would know more. Again, like I'm on the west side of the city, and we had events in some of these places, but officially we don't have events there because the conservation area doesn't, like, this is another problem is a lot of conservation areas and parks don't want you to be there at night because they figure you're up to no good. And like, you don't want to be there and have their enforcement officers pull in and hit you with the high beams. That would be a bad observing night. So yeah, but like I say, we used to have events there that we kind of publicized, I believe, Tom, but we do not do that anymore, not officially.
Yeah, we've had some issues post-COVID. A lot of places got fenced off, and things like gates were put on parking lots and the like. So used to be you could drive in under the cover of darkness and set up, and no one would care. And now there are things like gates on the parking lot entrances and cameras that are operate motion sensors. So,
okay.
Questions online? Nope, no questions online. All right, Ed, thank you very much.
Mm-hmm.
So, ladies and gentlemen, that concludes our speakers for the evening. Now, we're going to switch over to fun facts for a quick moment, and then we are going to have the announcements by our president, Scott Masterton, who will be joining us remotely. Just a reminder that after the meeting, there are going to be some telescopes set up on the roof of the Arboretum parking lot, which is the parking structure that is across from to the south, the Petrie building. Why you guys don't call it the Petri dish, I don't know. But anyway, so yeah, as soon as this meeting is over, if you want to go take a look through some telescopes, go right ahead. Yeah, so we're going to switch over to fun facts now. Then, so ladies and gentlemen, now a few words from the El Presidente. Ladies and gentlemen, Scott Masterton.
Thank you, Tom. And it's a pleasure to be here, and we're glad to have everyone with us. I have a public service announcement. The hockey game is now Florida 3 and the Maple Leafs 4. So, and we're midway through the third period. Okay, I want to explain what we do here. Tonight, you're experiencing the Recreational Astronomy Night, or RAN, which is in person and online. And we have various interesting stories from our members who will explain some of their projects. And of course, we get the sky this month. In another 2 weeks, we have Speakers Night, which is online only. And you're able to ask questions, as you've seen, and perhaps introduce yourself if it's your first time. The Carswell Observatory tours will occur every Wednesday. And as well, as Tom just explained, you can go to the top of the parking garage and the Arboretum parking garage and set up your telescope and view the sky. The city star party in Bayview that Ed explained, described, Bayview, it's available, relatively dark, and it's Tuesday or Thursday night between May 5th and 8th. And I believe last night it was not a call, so perhaps tomorrow night they'll be viewing. Please check the website for go, no go. And next speaker's night, May 21, is speaker Ethan R. Siegel, theoretical astrophysicist and science communicator. He's going to tell us about the James Webb Space Telescope. You can see that here in 2 weeks. The DDO Sunday stargazing, Sunday, May 25th at 12:30 to 1:30. Check the website for information and timing and fees. And save the date. The open house and awards picnic at the CAO up in Collingwood is Saturday, July 26th, and we'll have more information about closer to the date. The Carr Astronomical Observatory, where we're having the OHAP, is accessible now year-round, and for bookings, you can go to the site and spend a few days up there enjoying the view. RASC membership is available at the national office website, mempub@rasc.ca. And of course, once you're a member, we would encourage you to give us a helping hand by volunteering, and you can do that at volunteer@rascto.ca. And after the meeting, we may visit the VMV's Bar and Grill, which is just opposite the main entrance to the university. And the fun fact, I explained last time about how we experience tides and how they're created on Earth. And did you know that the moon is drifting away from Earth? The moon causes the tidal bulge, which creates a daily tide as the Earth rotates. And as the Earth rotates faster than the moon, the bulge moves ahead of the moon's orbital position. Once it gets ahead, the moon pulls back on it, and it slows down the Earth's rotation. The Earth slows, losing energy, and the moon gains energy. And because of that energy boost, the moon moves away from Earth by an astonishing 3.8 centimeters a year. So it's very likely your grandchildren will see the moon. Have a good night. Thank you for joining us.